we're going to be able to find the sums of a geometric series. A geometric series is adding all of the terms of a geometric sequence. A geometric sequence, one more time, is a to the nth power, meaning a very specific term in the sequence, is equal to the initial term times your geometric ratio raised to the n minus 1. So the n minus 1 represents all of the terms before it. So if I have the 14th term, n minus 1 would be the term before it, which is the 13th, the 12th, and so on. So S sub n represents the sum of a series. So in order to solve a geometric series, there's a couple steps. First thing is be able to understand how to read it. So just like with arithmetic series, we still have that sigma symbol. That means you're adding all of the terms from I equaling 1, so you're starting with 1, all the way to 16th, the 16th term. Using the rule that your first initial term is 4, your ratio is 3, and you have n minus 1, meaning all the numbers before it, we're going to add those all together. So let's go ahead and break that down. We know that a sub 1 is equal to 4 and r is equal to 3. And I represents whatever term of that sequence. So now we're going to just go ahead and plug it into the equation for series. So a sub 1 is going to be the initial term. And inside of it, we're going to be taking a look at finding the sum of all of those terms. So r sub n would be your ratio to that specific term. So in our case, the 16th term, minus 1. And then being divided by your ratio minus 1. Whenever you get that answer, you're going to multiply it by what that initial value was. In our case, it's 4. So let's go ahead and plug all that in and see what we get. When we plug it into the equation for the sum, we would get 4 times, in parentheses, your ratio 3 raised to the 16th power, because n is your 16th term, minus 1, and then over 3 minus 1. When you put that all in your calculator, you would get 86,093,440. That would be the sum of all the numbers from 1 to 16, or the terms of 1 to 16, using that equation for a geometric sequence. Let's take a look at another example. In this one, we have sigma, which means sum. This time, we're also starting with 4, and our ratio is 3 over 2, and we know n is 6. So if we plug that in, we would get your sum is equal to your first term times our ratio of 3 halves raised to the 6th power minus 1 all over 3 halves minus 1. So if we plug that into our calculator, I would recommend doing 3 divided by 2 raised to the 6th power minus 1, and then dividing it by 3 halves minus 1, and then multiplying that answer by 4. So when plugging that in, we would get 83.125. Let's take a look at a word problem. This one, you have to kind of pick out the pieces. And again, we need a sub 1, and we also need to know your ratio. So we're looking at movie revenue from 1990 to 2003, and they raised about $5.02 billion. The revenue increased by about 5.9% each year. So first thing we're going to do is write a rule for the total box office revenue in billions of dollars in the year 1990, where that's going to equal 1. So we know from here that our initial value is the $5.02 billion, and then the rate comes from this percent. And if you remember back in exponential equations, we're talking about an exponential growth because it says that it's being increased. So an exponential growth, the equation for that was 1 plus r. So we have to convert that to a decimal. So the rate would be 0.059, but then I have to add the rate to 1. So r would be 1.059. The 1 is because it's earning 100%, and then that value times 0.059 each time. So the rule would be your initial term, 5.02, times your rate of 1.059 raised to the n minus 1 power. Now that we have the rule, now we can figure out the sum of all of those terms. So we would have sigma notation where n equals 1, and we know the rule is 5.02 times 1.059 raised to the n minus 1 power. Now the thing we don't know yet is n, like how many terms are we adding together? That comes from the year range. So in 1990, we know that is when n equals 1. So then in year 2000, that would be year 11, because remember 0 is equal to 1, so we're going to actually add 10 more. And then when we went 2003, we just add 3 more to that, and we get 14. So in 2003, we know n is equal to 14. Now we can go ahead and plug it into the equation for the sum. So we have our initial value, which is 5.02, and we multiply it by your rate, 1.059, and we're raising it to the 14th power, minus 1, all over your rate, 1.059 minus 1, and then we just plug all that in. So when you plug that in, you'll see it's like 104.7 whatever, but remember that's in billions. So it's going to be approximately $105 billion.